Good morning, students. Today, let us see dealing with errors. Right. So, here we are going to see the techniques for preventing errors being introduced into our solution. We are going to discuss how to mitigate the effects of errors that are introduced, and we are going to introduce a systematic approach to testing via top down and bottom up strategies. And finally, we are going to test individual parts of the solution in isolation. Right. So, initially, let us see what is bug. A bug is a fault in a solution that can cause erroneous behavior. Bugs can be caught and eliminated at any stage in the development process, but the earlier you find and fix them, the better. Next, error. Any behavior observed when executing a solution that does not match the expected behavior. Some bugs only become apparent after your solution has been put into effect. For those cases, you need different approaches, namely testing and debugging. Next, we'll see designing out the bugs. This section examines the various types of bugs that can cause erroneous behavior. Typos. During the early planning phases, your solution exists in various design forms like documents, notes, diagrams, algorithm outlines, and so on. The simplest way of preventing errors at this stage is to look for elementary mistakes in both the problem definition and your solution. So the typos include spelling errors, incorrect capitalizations, missing words, wrong words, for example, phrase instead of phrase, and the numbered list with incorrect numbering, and so on. Such mistakes may often be trivial, but any of them could cause problems. The next one in designing out the bugs is poor grammar and ambiguities. Like typos, some types of grammatical error are quite easy to locate and correct. It's easy to find the mistake in this sentence, right? However, some grammatical errors are quite subtle. After having a coin inserted, the user will be able to push the turnstile. Right. So we are supposed to read the sentence and we are supposed to identify the mistake and correct it. And we should avoid the ambiguity. Right. The next point is inconsistencies. Eliminating ambiguities helps to counter another source of bugs, namely inconsistency. And inconsistency arises when parts of a solution separately make statements that make no sense when considered together. Right. Next, logical and mathematical errors. So if x greater than y, then print y. Otherwise, if y greater than x, then print x. So it's useless. If x is greater than y, then print y. Otherwise, print x. Once again, we need not have the condition checking. Next one is being exhaustive. So, being exhaustive here, what it means is computers have no common sense. They will not try to fill in any gaps in your instructions and they can't conduct a dialogue with you to pin down exactly what you meant to say. So, it is you who are supposed to complete everything, right? Then, general tips. Okay, finally, if the problem definition came to you from someone else, call on that person to verify your solution design. Unless and otherwise you understand the problem definition, you cannot find the solution. Right. Next, we'll see mitigating errors. So far, here we saw preventing actions that can take to stop bugs making their way into your solution. The bad news is that your finished solution will very likely contain bugs despite your best efforts. The good news is that steps exist for you to take against errors. The following sections examine what you can do to mitigate their effects. Right? The first one is getting defensive. Second one is reacting to problems, and the third one is checking user input. The very important part in our programming is testing. It is a method for locating hidden bugs in a fully or partially working system. Right? Here, the important point is goal, approach, and testing individual parts. What is goal? The aim of testing is to use the actual system you have produced in order to verify whether it performs as expected and to identify specific areas where it fails. Right, so there are two approaches in testing. First one is a top down testing and the next one is the bottom up testing. The third important point in testing is testing the individual part, because as we saw in decomposition, the complex task will be divided into simpler tasks. So these simpler tasks are independent and it will be coded separately and tested separately, right? And finally we'll do generalization, that is we'll integrate them to get the final solution. So we'll see what is the advantage and disadvantage of top down and bottom up testing. Top down, it is effective for finding design flaws. It can be encouraging to test a full system even if it is incomplete or contains bugs. The disadvantage of top down testing is it is difficult to apply when the system is incomplete. It requires you to use placeholders for the unfinished parts to simulate their behavior. It is harder to localize bugs when errors occur. In the bottom up approach, it is easy to apply in early stages of development. Right? It is effective for localizing problems because we'll solve the simpler task, then we'll merge them and then we'll find the solution for the complex one. The disadvantages requires you to simulate the controlling parts of the solution. It does not expose design flaws until much later. Right? So, finally, the summary is bugs are mistakes that can cause errors in your solution. Numerous techniques exist either to prevent bugs making it into your own solution or to deal with them after they have made their way in. Preventing bugs from getting into your solution means careful design effort. The earlier bugs are found, the cheaper they are to repair. Now, mitigating errors means anticipating and controlling their potential consequences. Programming defensively is a great way to prevent bugs causing havoc. Hunting for bugs and removing them is done by testing and debugging. Testing lets you search for bugs, and both top down and bottom up strategies offer systematic ways to approach testing. Debugging use logs or tracing helps you to keep track down the ultimate cause of errors. Thank you, students.